Yes, hello everyone. So, welcome you all again in the next session of the series of revision plus backup, where today we are going to study logarithmic functions, exponential functions, properties of logarithm, graphs of both logarithmic as well as exponential function. Then, some inequality based on logarithm we'll try to practice, right? And as always, yes, after the chapter I'll in this video only or in the upcoming videos I'll be going for practice sessions also, right? Let's get started without wasting any time. Logarithm. Yes, many individuals are fearing of these new things, but this is something which is very basic. Logarithm, yes, again it is some, basically it is a tool, right? Actually entire mathematics is a tool, but this tool it is used to find out anti-exponent. We can also say it is anti-exponent function or anti-exponent. What does it mean? One person, logarithm was discovered by one person named as John Napier. Okay, John Napier, who discovered this technique of logarithm in order to solve some complex powers, right? How? Say for example, if I'm telling you 5 square, this is some exponential form, it is written over there. We are knowing it is 25. Okay, but if I'm taking log on both sides, log 25 base 5, so logarithm is actually giving us answer as exponent. Yes, this is what we are calling base of logarithm, this is argument of logarithm, and ultimately answer we will be getting as exponent. So I'll be reading it as which power I should apply on 5 so that we'll be getting 25, right? Logarithm, it is basically giving us what, which power I will be applying on 5, so that I'll be reaching up to 25. So for obvious reason I need to give 5 power 2, right? So logarithm is answering basically exponent. Okay, that means sir, if we are having log 216 base 6, that is 6 cube, right? That means we can write it as 3 over there, right? Or else this anti-exponent, if I'm taking exponential function, this 6 will be moving other side, will be getting 6 cube is equal to 216, isn't it? Right? So basically logarithm is some anti-exponent technique so that we will be getting answer as exponent, right? Ultimately it is going to give us exponent basically, right? Okay, that means sir, if I'm finding log of 1 by 2 base 2, which power of on 2 we should apply so that we'll be getting 1 by 2, it is minus 1. Yes, if I'm finding 2 base 1 by 2, minus 1 again. It means log of n base n, it is always equal to 1 log of n base 1 by n, or log of 1 by n base n, that is equal to what, minus 1. That is what we are doing. Okay, what is log 1 in that case? Sir, log 1 base, which power on 5 will be applying so that we'll be getting 1? Log 1 is always 0, right? 5 power 0, it is equal to what? 1 in that case, right? Okay, just a second. Yes, okay, sir, that means what about if we are having log of minus 1 and 2 here? Which power on 2 will be applying so that we will be getting minus 1? Sir, we won't be able to get, because if we are applying negative power also, no, 2 power minus 1 what? It is 1 by 2, and we will never reach at minus 1. So sir, first thing we came to know that if we are having y is equal to log x base a, okay, so this x must be always positive. X is negative, log won't be defined. Okay, sir, in the similar fashion, if we are having log of, yes, minus 2 base 1, that is also not defined, right? Any power on minus 2 never going to give 1, right? Or else if we are having log of 2, let's say we are applying log of 2 and base is minus 2, which power on minus 2 will be giving 2? Not defined basically, right? In that case I will be telling like a must be greater than 0. Okay, sir, if we are having 5 here and 1 here, which power on 1 I should apply so that we'll be getting 5? Any power of 1 is always 1, it is not equal to 5 anytime. In that case you can say it is also not defined. That means base cannot be equal to 1. So whenever logarithm will occur, it will always occur with 3 necessary condition, that is x greater than 0, a greater than 0, a not equal to 1. If these 3 conditions are not satisfied, we won't be able to define logarithm. Keep it in mind. Yes, again I'm writing, yes, y equal to log x base a is defined for three conditions, everyone. Keep it in mind every time whenever you will be encountering logarithm, first three things you must be knowing: x greater than 0, a greater than 0, a not equal to 1. If these three things are not there, then a logarithm is not defined only. Whatever answer you will be getting is vague, right? Yes, so three conditions to define logarithms. So some basic things also we have written. Let's say n is greater than 0. Okay, if n is greater than 0, we are knowing log of n base n. Which power on n I'll be giving, so that I'll be getting n 1. Okay, log of 1 by n base 1 n, or else log of n base 1 by n, that will be equal to what? Minus 1. Okay, also with that we are knowing log of 1 base a or 1 base n, it is always equal to 0. Anything to the power 0 is always 1. These basic three things we need to know for logarithm, right? Yes, next topic we are moving into is properties of logarithm. Yes, properties of logarithm. Yes, bacha log, very important topic. Again I'm telling you, direct questions they are rarely asking, but used multiple number of times in the questions, right? Okay, properties of logarithm. Let's say we are having this a1, a2, a3, they are all greater than 0. Also with that, if we are having m n greater than 0, and let's say this is not equal to 1, a not equal to 1 also, right? So these are the three things we are having. Now we are writing the property. First property, log m base a plus log n base a, that is always equal to log mn base a, provided log is defined, right? Sum can be converted into product, or product can be converted into sum easily. Sir, how? Proof also simultaneously we'll see. We have used multiple number of times till now, right? So by the time you must be knowing this property, but let's say we are solving it with proof. Let's say x is equal to log m base a. So if I'm writing exponential form, in that case we can write m is equal to a power x. Similarly, let's say y is equal to log of n base a. So n, in that case, if we are writing, what we can write it as log of, tell me, sorry, not log of, a power y. N is equal to a power y. Okay, now let's say if I'm multiplying these two expression, first and second, right? If I'm multiplying these two expression, what I'll be getting, mn is equal to a power x into a power y, which is a power x plus y, correct? A power x plus y, that is what we'll be getting. Now if I'm taking log both side, base a, log of mn base a is equal to log of a power x plus y base a. Now tell me which power on a I'll be giving, so that I'll be getting a power x plus y. Simply आप लोग सोचो ऐसा, which power of on 5 I'll be giving, so that I'll be getting 5 square, for obviously 2, right? So here also we can easily say log mn base a, that is actually equal to what? X plus y. What is x? Which is log m. What is y? That is log n. So log m plus log n, from here we can conclude that it is equal to log of mn. Yes, provided base are same. If base are same, we will be having two logarithm in addition can be converted into product, or product can be converted into addition, right? So this is what we are having the first property. So in case if we are having multiple logarithm involved, say we are having log of m1 base a plus log of m2 base a. Let's say this is property first a part, right? Extension of first property, log m2 base a and so on up to log mn base a. Okay, in that case, sir, multiple n logarithm are added, base are same, so we can convert it into log base a. Here we can write it as product m1 m2 m3 and so on up to mn, right? So multiple logarithm with same base, if they are added, they can be converted into product also, right? Using the same property. Okay, we are calling it as 1. So second property. Second property. If we are having difference of logarithm, log m base a plus log n base a. Instead of plus, say we are having minus here. Okay, that can be written as, yes, that can be written as log of m by n base a. Okay, we can also write it as log of m by sum can be converted into product and difference can be converted into division. How it is so? We'll see. Everyone, for that purpose, again the same method. Till here we are having the same thing, right? So let's say m is equal to a power x and n is equal to a power y. Instead of multiplying this time, let's say if I'm dividing, what I'll be getting? M by n, that is equal to a power x minus y. Now if I'm taking logarithm both the side, yes, log m by n base a, yes, that is equal to log of a power x minus y base a. Now which is again equal to what? X minus y. Yes, and x minus y is nothing but log m minus log n, right? Log m minus log n, that is equal to what? Log of m by n, right? So difference can be converted into division, and yes, sum can be converted into product in case of logarithm. Correct? If base are same, provided base are same. Next property, everyone. Fourth one. Log of m to the power alpha base a, that is equal to alpha times log of m base a. If we are having any power in argument, that will be moving into the product in case of logarithm, right? The power of argument will be moving into the product, right? How it is, that also we'll try to explore. Yes, this property I'll do the proof. The next property you can directly memorize. Yes, so sir, log of, yes, tell me, m power alpha, can I write it as m into m into m? How many times? Alpha times, yes, alpha times m. Now you people will be letting me know, sir, product can be converted into sum. We can write it as log m base a plus log m base a. How many times? Log m base a. How many times? Alpha times. Yes. Now if I'm adding alpha times the same thing, what I'll be getting? Alpha times log m base a, and which is actually equal to log of m to the power alpha base a. Right? So from here clearly we can say, if we are having power of argument, that will be directly moving into the product. Okay. Next. Sir, इसी का extension, if we are having log of m base a power beta. So if we are having power of base, that will be moving into the denominator, 1 by beta log of m base a. So if you are having combined power, log of m power alpha and a power beta, in that case we'll be getting it equal to what? Alpha by beta times log of m base a. Isn't it? Combinedly you can apply that particular thing. Yes? So that is what we are having. Till here I hope it is clear to all of you, right? Okay. Now we want try and understand next, which is very, very, very important property. Again I'll be going it for, yes, that is base change theorem. Base change theorem, a base change property, right? Very, very, very important property in logarithm. Okay, sir, if we are having log m base a, we can write it as log of m by log of a, and base we can give anything according to our choice. Let's say here I'm writing b for the time being. Any base we can provide, which is valid, right? Base must be greater than 0, base not equal to 1, right? So any base we can give apart from those which are not satisfying the given condition, right? Logarithm satisfy hona chahiye, right? Any base according to the question which is suitable for us we can give, right? This is what we are having, base change property. Proof kar दें. Yes, proof. Yes, everyone try and understand. We are having log of m base a. Let's say I'm assuming it is equal to x. Okay, now what I'll be getting? M equals, tell me, a power x. Yes. Now everyone, log of m base b, we can write it as log of, tell me, log of m base b by log of a base b. Yes, the right hand side RHS. Okay, we can write it as log of m, we can replace it by a power x base b divided by, tell me what I'll be getting, log of a base b. Now sir, power of argument will be moving into the product, x time log of a base b by log of a base b, isn't it? This will get cancelled or will get log of, yes, log of m base b by log of a base b. It is actually equal to x. And what is x equals? What is x equals? Which is log of m base a. Yes or no? That is what we have written over here, isn't it? That means any logarithm, say for example, if we are having log of 16 base 4, clearly you are knowing answer is 2. Which power on 4 I'll be giving so that I'll be reaching up to 16, right? 2. But we can write it as log of 16 by log of 4, let's say. Now if I'm providing base as 2, which power on 2 I'll be giving so we'll be reaching to 16? 4. 2 power 2, which power will apply so that we'll get 4? 2. Ultimate answer again 2. Right? So this is what we are calling it as base change theorem. Any base we can apply provided, yes, that must be valid base, right? We are calling it as base change property. Clear? Next. If you want to write, you can pause the video and write, okay? Next. Reciprocal property. Yes, all of you. So what we are having, sir, it is extension of base change theorem only. What we are having, say we are having log of m base a. We can write it as 1 by log of base and argument will be interchanged with each other. Log of m base a also we can write it over here. How? We'll see. Sir, log of m base a. Just now we have studied that we can use base change theorem and we can provide any base according to us. So we can write it as log m by log a. Now what I'm doing, I'm writing the base as m. Now tell me what is log m base m? That is 1, right, by log of a base m. That is what we are getting, and that is, it is written over there, right? We are calling it as reciprocal property. If base and argument we are interchanging, it will reciprocate the algorithm. Clear? This is what we are having, the another property. Next. Yes. Identity we are calling it as a power log x base a. Here, look, a here and a here. So look, what basically we are doing, you are knowing, you have studied multiplicative inverse. 2 into 1 by 2 if you are doing will get 1. It is likewise, a power something, this is exponential function and logarithm is anti-exponent. So we are taking exponent of anti-exponent, will get the x itself. It is always equal to x, right? Provided base at both the place, it must be a only, right? If it is same, we can say a power log x base a, that is actually equal to x, right? So how it is, we'll see the proof also. It is very basic thing, right? Say log x base a, right? I'm assuming it as p. Yes. Now from here x we can say it is equal to what? A power b, right? So x is equal to a power, what we have assumed p as, write it log x base a. So a power log x base a, it is actually equal to what? X only. Yes or no? Right? So it is basically anti-log of logarithm, right? So definitely it is equal to what? Tell me. It is equal to the x value itself, right? Till here I hope everything is clear, right? Next thing we are moving into is graphical part, right? We are going to use all these properties while solving the questions. You people can note it down. Yes, you're having option, right, to pause the video and note down while solving questions. Definitely I'll be helping you out, right? Okay. Next is graphs of logarithmic function. Yes. So sir, let's say we are having logarithmic function y is equal to f of x, which is actually equal to log x base a. Yes, this is certain logarithmic function we are having. Sir, provided three conditions always we will be keeping in mind, which is x greater than 0, a greater than 0, a not equal to 1. If logarithm we want to define, three condition always we will be taking care of, which is x greater than 0, a greater than 0 and a not equal to 1. Okay. Sir, in that case, sir, two cases we are making it over here. Case 1. right? Sir, base is greater than 0. So I'm taking two cases. First case is a greater than 1 and second case I'm taking as, yes, case 2 where a is between 0 and 1, right? So these are the two cases I'm taking for to draw the graph of logarithm. Okay, so for that purpose, let's say we are having y equal to log x, right? Now base we are taking as greater than 1, any value greater than 1. Let's say we are taking 2. Okay, for the time being some basic graph will be drawing and then we'll generalize it. Okay, you people will be helping me out. If I'm forming the table, what I'll be getting, yes, yes everyone, help me with this. Let's say it is x, y. Now for different x value, let's say x I'm taking, sir, x we need to take strictly greater than 0, that we need to keep it in mind, right? Okay, let's say if I'm taking x equal to 1, which power on 2 I'll be applying so that I'll be getting 1? 0. Okay, if I'm taking x is equal to 2, which power on 2 I'll be applying so that I'll be getting 2? 1. Okay, then let's say x, if I'm taking 1 by 2, what I'll be getting? Minus 1. 1 by 4, minus 2, 4, 2. All such points, let's say we are plotting and joining. Okay, at x equal to 1, y value is 0. At x equal to 2, y value is 1. At x equal to 1 by 2, y value is minus 1. All such points, if I'm joining, parallel to x-axis and so on. So this is what we are going to get the graph of y is equal to log x base a when a is greater than 1, right? So this is graph for positive x-axis only we will be able to draw the graph. Why so? Because clearly we are knowing x must be greater than 0, otherwise this function is not defined. So few terminologies are there. First of all, as x values are increasing, graph is increasing its value or decreasing its value. So graph is also increasing. See, as x value is increasing, graph is going above and above, right? That means it is increasing graph. Increasing graph. Okay. So when we will be getting increasing graph? When we are having a greater than 1, we'll get increasing graph of logarithmic function. Clear? So secondly, domain. What is domain of the function? Domain is basically permissible x values or else width of the graph. You can clearly see width of the graph is this part only, right? Along x-axis, graph is spreaded from 0 to infinity. For 0 to infinity value of x, graph is defined. Exactly 0, not defined. Exactly infinity, it is infinity. Right? Okay. So what is range? Range is height of the graph or possible y values. So possible y values, sir, y value we can get 0, negative, positive, every value is possible. Or else height of the graph we can see. This graph is having height from minus infinity to plus infinity. Entire graph is covered, so you can say range is y belongs to all real number or minus infinity to plus infinity in that case, right? Okay, so that is clear. Next, let's say we are taking case 2. Case 2 is when we are having a is between 0 to 1. Okay, a is between 0 to 1. So let's say I'm taking a half. That will be okay for you, I guess. Yes, you people help me with the table. X, y. If I'm putting x is equal to 1 again, which power of half I'll be applying so that we'll be getting 1? 0. Yes or no? Then let's say we are having half here. Half base half, log of half base half, 1. If I'm having 1 by 4, 2. If I'm having 2, which power on half I'll be applying so that I'll be getting 2? Minus 1. Okay. Which power on half I'll be applying so that we'll be getting 4? Minus 2. Or half power minus 2. Simply half power minus 2. We can write it as 2 power 2 in that case, which is nothing but equal to 4. You people are very much aware about. Right? Basic power surds you people are able to solve. Right? Yes, this is what we are doing. If I'm plotting all such points, everyone, see what sort of graph we'll be getting. Look, rough and you people won't be drawing the graph using some scale, rubber or something like this. Directly, freehanded graph I would appreciate here. Right. Tell me at 1 will be getting 0. Yes, done. 1 will be getting 0. Yes, clearly here also we are having this point as 1 comma 0, right? Okay. So at 1 will be getting 0. At half will be getting 1 here. At 1 by 4 will be getting 2. And likewise it is going on. Okay, sir. So likewise we'll be getting the graph. Yes, this point is 1 comma 0. At 2 we are getting minus 1 here, right? Correct. So likewise this decreasing graph will be getting. Decreasing graph of the function will be getting it over here. Just a second. Just a second for a moment. Wait for a while. Yes, sorry for the disturbance. Yes, everyone. So we are at the decreasing graph. Okay, graph is decreasing here. Then we are having domain. What is domain of the graph? Tell me. Domain, sir, same. X belongs to 0 to infinity. Height of the graph. Height of the graph, sir, it is covering entire y-axis, right? Entire y-axis it is covering. Along y-axis entirely we'll be having the graph. So that's why we'll be telling like range is all real number. Yes. So y belongs to all real number. That is what we are doing. Okay. Yes. So this is what we are having the graph of this logarithmic function. Okay. Yes. Next, sir, simultaneously let us draw the graph of exponential function. We'll study exponential function simultaneously, right? Yes. Yes. Exponential function. If any doubt you are having, you can post me, right? You people are having my number, you can post me the doubt. I'll clear it then and there itself. Or else in the class, regular classroom, you people can let me know the doubts, right? So I'll be clearing those doubts there. Now you people tell me exponential function, everyone. Exponential function, the type will be y equal to f of x is equal to a power x. This is what we are having exponential function, right? So provided here also we are having two condition, a greater than 0, a not equal to 1. So if a is equal to 1, anything to the power 1 will be always 1, right? It will become a constant function, it won't be exponential function. A greater than 0, a. So logarithmic function always coming with three condition, x greater than 0, a greater than 0, a not equal to 1. But in case of exponential function, we are only having two condition, a greater than 0, a not equal to 1. X can be negative this time. Okay. So here also we are having two type of graphs. We'll see one by one. So y equal to a power x when a is greater than 1. Okay, we'll see. Sir, a is greater than 1. Say for example, we are plotting the graph of y equal to 2 power x. You people help here? Yes, you people help. What I'll be getting? Sir, table if I'm forming. See. Now you people x, y. Now if I'm putting x is equal to 0, y will be 1. If I'm putting x equal to minus 1, y will be 1 by 2. If I'm putting x equal to minus 2, 1 by 4. 2 power minus 2, 1 by 4. If I'm putting x equal to 1, 2, 2 if I'm substituting it is 4. And likewise it is going. So if I'm joining all these points, sir, at x equal to 0, y will be equal to 1. Okay. X equal to 2, y will be equal to 4. And likewise it is going on. So if I'm joining all such points, we'll get some exponential increase. Right? This is what we are having the graph. We are calling it as graph of a power x, y equal to a power x, provided a greater than 1. Yes, this point is 0 comma 1. Right? This point is 0 comma 1. Earlier in the logarithmic function, we are getting a point 1 comma 0 over there. Right? Yes, this is what we are having the graph over there of x, a power x when a greater than 1. Okay, clearly it is increasing function. Okay, secondly, increasing function. Okay, now secondly, what we are knowing, domain is, sir, width of the graph. This time width of the graph is all real number. Range, what is range? Sir, height of the graph. Height of the graph, it is starting from 0 and it is going up to infinity, right? The graph along y-axis, it is not below x-axis. So y values are from 0 to infinity. This is what we are going to get. Right? Sir, second case, if I'm taking, that is y equal to a power x when a is fractional value between 0 to 1. Say if I'm taking a is equal to 1 by 2. Okay, for the time being. So let's say we'll be getting y is equal to 1 by 2 power x, or else we can also say it is 2 power minus x. Right? This graph. Okay, we'll see. You people will help me forming the table. Yes. X, y. Yes. So sir, let's say if I'm taking power as 0, something to the power 0, 1. If I'm taking power as 1, we'll get half. If I'm taking power as 2, 1 by 4. If I'm taking power as minus 1, we'll get 2, right? Power as minus 2 will be getting 4. Likewise, we'll be getting, right? Okay, so if I'm plotting them on graph, what I'll be getting? At 0, we'll be getting 1. That is for sure, 1 at the same point. At 1, we'll be getting half. At 2, we'll be getting 1 by 4, right? And so on, it will be decreasing likewise. At minus 1, we'll be getting 2. So all such points, if we are joining here, free-handedly, so we'll be getting certain graph, and this graph is we are calling it as exponential decrease function, right? Again, I'm free-handedly drawing the graph. We'll be getting this sort of graph. Yes, y equal to a power x when x is between 0 to 1, we'll get this graph. This is decreasing function. Domain and range are still same because graph is spreaded across x-axis, but height of the graph is 0 to infinity, right? That is what we are going to get it over here, isn't it? Tell me. Okay, so this is what we are having actual function over there. Now sir, so basically now if I'm drawing simultaneous graphing over there, you people try to understand, right? I'm drawing simultaneous graph of log and exponential function. You people are knowing they are anti of each other. Anti means they are basically inverse of each other, we can say, right? Now, so what is inverse? Separately we'll be discussing inverse of a function in next chapter or the function chapter, but for the time being you try and understand. So graph, logarithmic graph. Let's say this is what we are having, 1 comma 0. So y equal to log x. Yes, this sort of graph we'll be getting for y is equal to log x. Yes, this is what we are having, y is equal to log x base a when a greater than 1. But sir, what is exponential graph? Exponential graph, or else let me use the different color so that it will be easy for me. This exactly inverse of this, right? This is what we are having, y equal to a power x graph when a greater than 1, right? And this line is reference line, which is y equal to x line. Okay, so you can see both the graphs are symmetrical about y is equal to x line. Graph of yes, y equal to log x base a and y equal to a power x are symmetrical about y is equal to x line. Okay, for the time being you are not knowing, but if graphs are symmetrical about y equal to x line, we are calling both the function or both the both the functions as inverse of each other, right? That means here you can write, so both are inverse of each other. So what about other graph? Is that also it is symmetrical about y equal to x line? Let us see. Everyone try and understand. Let's say we are forming that particular graph also. Yes. So logarithmic decrease graph. So logarithmic decrease graph will get likewise. Yes. Likewise. Okay. And exponential decrease graph will get likewise. Yes. This is what we are having. And let me use different color for this graph. Okay. Let's see. Yes. In between, this is y equal to x line, we are having it over here. Wait, the graph, I guess, the intersection point of the graph is different. So let's say we are having y is equal to x line here. This is y equal to x line. And this is what we are having, graph of decreasing exponential function. Right? Now clearly visible, they are symmetrical of each other. Again, y equal to x line, about y equal to x line. Are yes or no? This part here, it is exactly symmetrical with respect to this part here, right? So this is what we are having, graph of y is equal to a power x when a is between 0 to 1, right? And this is what we are having, graph of y is equal to log x base a when a is between 0 to 1, decreasing number. So logarithm and exponential function, we are calling it as they are inverse of each other. Secondly, they are symmetrical about line y is equal to x. Till here, I hope it is very much clear to all of you, isn't it? Okay. Now, next, yes, sir. Now, sir, increase, decrease, two type of graph we have studied. So, what is the use of all these things? basically these are very important while we are dealing with inequalities. Yes, inequalities. Let us form two cases and try to understand. Yes, everyone, all of you, say we are having logarithmic increasing graph, it will be likewise. Yes, say we are having 2 points here clearly, x1 and x2, which is in right side, x2 obviously, so clearly we can say x2 is greater than x1. Okay, with respect to this x1 we are having y1, which is nothing but log of x1. Yes, with respect to this x2 we are having y2, which is log of x2. Yes, base a, let's say we are telling like, and a is greater than 1. Okay, a is greater than 1 means we will be having increasing graph. Now you tell me, log of x2 is greater or log of x1 is greater? Obviously log of x2 is above, so in that case we can say, if I'm taking both sides x2 base a, so log of x1 base a, log if I'm taking both the sides, so definitely we'll be getting the same orientation of inequality. Okay, sir, if we are having a greater than 1, that means if base is greater than 1, that means if we are having increasing graph of logarithm, then if we are taking logarithm on both the side or anti-logarithm on both the side, the inequality orientation will remain same. Okay. So what about decreasing function in that case? Yes, we'll see. Okay. Let's say we are having decreasing logarithmic curve likewise. Okay. Now if it is decreasing logarithmic curve, here we are having x1 and here we are having x2. Clearly visible, x2 is on the right side on x-axis, so x2 is greater than x1. So decreasing graph means a we are taking between 0 to 1. Okay. Now sir, with respect to x1, here we are having log of x1, right? Yes. Now here, with respect to x2, here we are having log of x2, right? Now clearly visible, sir, log of x2 and log of x1, which one is greater? The above value on y-axis is greater, above value is log of x1. Okay, sir, if we are having decreasing function and if we are taking logarithm on both the side, when base is a between 0 to 1, which means it is decreasing graph, then inequality orientation will reverse. For increasing graph or for a greater than 1, inequality orientation will remain intact. But when a is between 0 to 1, inequality orientation will simply reversed. Isn't it? Tell me. Yes? So this is what we are going to get it over here. I hope till here it is clear to all of you. Yes? Okay, one or two questions we are going to practice and then we'll wrap it up. We'll start with some logarithmic inequality based question. Okay, before that, you people are not aware about ln and log base 10. So basically log, generally we are using two logs, two types of logarithm in chemistry and mathematics specifically, right? Maths obviously we can take any value, but yes, two types are basics. We are having common log and natural log. Yes, common log means it is log x base 10. If I'm taking base as 10, yes, we will be naming it as common log. Generally you will be using this base for chemistry uses, right? In maths we'll be using natural log. Mostly, it's not like we cannot use other, but mostly we'll be using natural log. Natural log means base is e, log x base e. So what is e? E is basically Napier's constant. Obviously Napier's created this technique, so this is Napier constant. What is its value? Its value is irrational number 2.71 and so on. Keep it in mind, right? Some irrational number, like we are having pi is irrational number 3.14 and so on. So this is also irrational number 2.71 and so on, and it is, we are calling it as Napier's constant, right? E basically, and for obvious reason e is greater than 1, 2.71, so graph will be increasing graph if base is e, right? Likewise we'll be getting the graph, isn't it? Okay, we are using sometime ln x also. We are also naming it as ln x sometimes. Ln means natural log, we are calling it as. If ln is given, you people will be thinking its base is e. And mostly in maths, we'll be using ln x only. Okay? Now we'll be jumping into the questions directly. One question for the time being we will be solving. One, two question I'll be giving you as a homework. Remaining one extra practice session will be taking for exponential function as well as logarithmic function and logarithmic inequalities. Now we are moving into logarithmic inequalities, right? First question, it is, you people will be telling sir it is tough. It is actually not. Okay, we'll see. Now this is some inequality based question. You can pause the video and try to solve by yourself. Otherwise, yes, you can refer wherever you are struggling in between. Yes. So sir, ln x whole square minus 3 ln x plus 3 by ln x minus 1 less than 1. Sir, we have studied inequalities using wavy curve method, in which polynomial by polynomial we are having. But here we are having logarithmic function. Okay. What I'm doing doing one thing. This ln x, I'm assuming it as p. So what I'll be getting actually, p square minus 3p plus 3 by p minus 1, it is less than 1. Okay. This one I'm taking on the other side. Cross multiplication is not possible in inequality. Keep it in mind. I told you yesterday itself in the last session. P square minus 3p plus 3 by p minus 1. Both the side, if I'm subtracting 1, will get less than 0. If I'm taking LCM, p square minus 3p plus 3 minus p plus 1 divided by, tell me, p minus 1, and it is less than 0. You people will be helping me out here. P square minus 4p plus 4 by p minus 1 less than 0. Okay. This is what, p minus 2 whole square by p minus 1 less than 0. So using wavy curve method on the number line, I'll be plotting 1 and 2, but I'll mark star at 2. Yes or no? Plus, minus, plus. Now somebody will be telling like, sir, not plus, plus, minus. Wait, plus, plus, minus. Sir, why plus, plus, minus? Because at 2 we are having what? Star. Star means sign won't be changing. Plus, plus, minus. In that case, you people help me out here. Yes, they are asking less than 0 means minus or plus? Minus. Minus means what I'll be answering over there. P belongs to minus infinity to 1. Isn't it? Sir, open interval, because we are having strict inequality over here. Okay, P belongs to minus infinity to 1. Okay, in that case, you people help. What is P? P is ln x, we have assumed as. And ln x is between minus infinity to 1. Okay, if ln x is between minus infinity to 1, you people help me out. ln x bole to base is e, log x base e. It is less than 1 and minus infinity here. Now you people let me know, e is what? E is greater than 1 or between 0 to 1? E is obviously greater than 1. Greater than 1 means increasing graph or decreasing graph? Increasing graph. Increasing graph means if I'm taking anti-logarithm, inequality orientation will be still same. Okay, if it is so, on the other side, what I'll be getting? Let's say, yes, everyone, what I'll be getting here? This e will be moving this side, e power 1 will be getting, and this side e power minus infinity. E power minus infinity, here we're left with x, here we're left with e power 1. What is e power minus infinity? E power minus infinity, it is actually equal to 1 by e power infinity, which is 1 by infinity, which is 0. So we'll be getting x is between 0 to e power 1, or else 0 to e. Which option? A option is absolutely correct answer. Likewise, you will be solving inequality based questions of logarithm. Able to understand, everyone? In the next video or next practice session, I will be giving you some more questions over there. You can take the screenshot, or else you can solve this question at your own, right? Pause the video and solve this question. This is your homework question. Another homework question for you based on logarithmic properties, right? Base change theorem, everything you will be trying, you will be solving this question. Same base change theorem, you will be trying, you will be solving this question also. Yes. So that is it for the day today. Some practice session I'll be keeping separately for this particular chapter over there, right? I hope till here everything it is sorted for you. So that is it for the video. Thank you, everyone. Yes, I hope you people will be studying accordingly, right? You are having some holidays, that is for sure. Enjoy your holidays. You won't be getting too much time afterwards, but for the time being, just go through some basics over there. जिसने नहीं पढ़ा specifically in the classes, right, who have joined later, those who have didn't practice on that particular time, they can refer these videos, create your notes, because these things we are going to use multiple number of times in the upcoming sessions, regular classroom sessions, right? That is it from my side, everyone. Thank you so much. See you in the next class, right? Thank you. Bye-bye.